video, we're continuing with example 8 from section 8.5, 8.7, 8.8. First thing we're going to do is look over here in the left-hand column. So for volumes of figures with known cross-sections perpendicular to the y-axis, so in addition to the x-axis, we can do the y-axis as well. We're going to sketch the graph, if not already done for us. Then we are going to rotate our graph 90 degrees counterclockwise. We're going to find A and B, but A is on the left and B is on the right using the y values for the intersections. Then we're going to solve our equations in terms of y, and then we're going to use the same steps we did in the other cross sections that we did earlier in the notes. So looking at example 8, the first thing I'm going to do is I'm going to take this and I'm going to rotate it 90 degrees counterclockwise. So that's what our actual function would look like. To get these 2 points of intersection here and here, we are going to use I have it calculated in here, we're going to use the y values in the graph of the original. So I'm going to use the 0.174 would actually, be this one would be 1.74, and then this one, not that one, would be negative 3.98. The negative 3.98. So I know that those would become my bounds. So it would be negative 3.98. And notice this is the A, this is the B. So the A, or is the one, sorry, did it say B or A? B is on the left. So sorry, this is the B, this is the A, because you always want your smaller one to go in the A spot. And really I should go a couple more decimal places. All right, then I've got to get these guys in terms of x. So it has to be x equals. So I know that I'm going to solve for the x. So I would start by adding the 4 equals x squared. I'm going to take the square root of both sides. Technically, I need a plus minus square root, but the catch here is that this red one here was the parabola. So this has to be the parabola. And notice I've only got the one that's above the x-axis, so I just want the positive one. So I'm just going to go with plus. And then I'm going to solve for my other one there. So I'm going to solve for this one here. I get y equals 2 natural log of x. I'm going to bring the 2 over, equals the natural log of x. And we know to get rid of the natural log, we have to exponentiate. So e to the natural log of x. So we get x equals e to the y over 2. We know that it's going to be the left minus the right, and my left is definitely my red function, so it's going to be the square root of y plus 4 minus the blue function, which is we found to be e to the y over 2, and then we're going to make this dy. And at this point, it's simply just punching it into our calculator. So what I would do with this is I would first of all, I'm going to copy these values here. I'm going to double click once, twice, Control C. When I come to this page, I'm going to hit a Shift plus, and I'm going to do Control V for the bottom one. I want those decimal places accurate. I'm going to do the Y value, Control C, Control V. And then I'm going to actually just type in my function. So it was square root of y plus 4. And then it's going to be minus e. And then it was y divided by 2. So y divided by 2. And then make sure you use a dy. And hit enter. We get 4.66577. There you go.